Welcome back. Let us look at the discrete source encoding algorithm. We have studied earlier that minimum number of bits required to encode a message is given as log of 1 by p, where p is the probability of occurrence of that particular message. Now this is true if all the messages are transmitted with equal probability or we have equiprobable messages. Now let us look at the generalized equation or solution where the messages are not transmitted with equal probability. Let us take a source M where there are n number of messages having M1, M2, M3 ... up till Mn. So there are n number of messages in the source M. Now these messages are transmitted with probabilities, let's say P1, P2, P3 ... Pn respectively. Now we will here consider a sequence of n messages, capital N messages, where n tends to infinity, and we will try to understand or calculate the probability of that particular message. We assume here that Ki is the number of times the message Mi occurs in the total sequence capital N. So according to relative frequency distribution, we can write that Pi, or the probability of occurrence of the message Mi, is given as limit n tends to infinity Ki by n, or in other words, the message Mi occurs n Pi times in the sequence of n messages. Let us go back again. Here I have written, according to relative frequency distribution, let Pi be the probability of occurrence of the message Mi. So we can write it as limit n tends to infinity Ki by n. Now from here we can write, what is Ki then? Ki is the number of times the message occurs, the message Mi occurs in the total sequence n. So that is given as Pi into n. Now let us consider a typical message Sn, which consists of capital N number of messages, and the probability of occurrence of the particular sequence Sn we have to calculate. Let us see how. So we can write P of Sn should be given as, how many number of messages are there? There are n number of messages. So we can write it as Pi to the power npi multiplied by P2 to the power np2 multiplied by P3 to the power np3, and so on up to Pn whole to the power npn. Now we have studied earlier, in order to encode this we need to calculate the number of information bits, and that is given as log of 1 by Psn. So we can write it as, if ln is the number of digits required to encode this message Sn, we can write ln as log of 1 by Psn. Now if you calculate it and put the values in this equation, then we can find that the value comes as n summation of I equal to 1 to n Pi log of 1 by Pi. Now what is this value? Summation of Pi log of 1 by Pi is nothing but our entropy, which we have already covered in the previous lecture. So we can conclude that the number of binary digits required to encode the message Sn, which is given as ln, comes out to be n times the entropy. Now what is the average number of digits required to encode that message? We just divide ln by n, so we get it as HM binary digits. So this is a very important equation which states that it is possible to encode messages emitted by a source using on the average HM number of binary digits or messages, where HM is the entropy of the source.